Chapter 2, Section 7 is called Implicit Differentiation. This chart shows 1, 2, 3, 4, 5, 6, 7 examples. In this course, we won't worry about these two examples right here. So, there's two columns here. Given and derivative with respect to x. If 7x is given, the derivative is 7. But what's new here and different is the derivative of 7x is really 7 times dx dx. It's really this number times the derivative of the thing next to it, which could be symbolized the derivative of x with respect to x. Ordinarily, we don't write that though. So dx over dx is 1. Anything over the same thing is 1. So when we say the derivative of 7x is 7, we are correct. However, 7y is different. Not really different though. The derivative of 7y is 7 times the derivative of what's next to the 7. So when someone asks me what is the derivative of 7y, I say 7 times dy dx. I don't just say 7. The next example in this chart is 4x to the 5th. Think of it as 4 with x in parentheses to the 5th. The derivative is what I've been calling the 4 bells. 5 times 4 is 20. The x gets copied. The 5 becomes a 4. But we also multiply by the derivative of what is in the parentheses. Right here. Inside these parentheses is x, and the derivative of x with respect to x is actually 1 dx over dx in the yellow. So the derivative of 4x to the 5th really is 20x to the 4th. But it's important to understand why I'm putting this thing in the yellow here, because the derivative of 4y to the 5th, you must think of the y as if it was in parentheses, even if it isn't, because we still require the 4 bells. Here we had the 4, but our 4th one ends up disappearing up here in the yellow, but not in the 4y to the 5th case. The derivative of 4y to the 5th is 5 times 4, which is 20. Check. The y in the parentheses gets copied right there. Check. The 5 becomes a 4. There's the exponent. Check. And we always multiply at the end here by the derivative of whatever's in the parentheses. This dy dx has to be there. In the example above, the dx over the dx can be left out, just because dx over dx equals 1. And this last example down here, x times y is a product. The derivative of a product is always the first times the derivative of the second, plus the second times the derivative of the first. First is x, the derivative of the second, that's dy dx, plus the second, that's the y, times the derivative of the first. Since the first is x, the derivative right here, use yellow again, that right there is actually 1. So the derivative of xy is actually all of this, according to the product rule. On page 292, exercise 16 says x to the 2nd plus 2xy equals 3y squared. And we are going to differentiate implicitly. The phrase differentiate implicitly means we're going to find the derivative of y with respect to x, differentiating. So we are not going to solve for y first. Implicitly means we're not going to try to get y by itself. So here's how this works. We first differentiate right off the bat. We say here's the x squared. Write down the derivative of x squared. The pluses and minuses and equals just get brought down. 2xy is a product. The derivative of a product, 2x times y, is the first, which is 2x, times the derivative of the second with respect to x, plus the second, which is y, times the derivative of the first. The first is 2x, the derivative of 2x is 2. All this green is the derivative of 2xy using the product rule. The first times the derivative of the second plus the second times the derivative of the first. The equal sign gets copied, and the derivative of 3y squared is 4 bells. 3 times 2. Ding. Copy the y. Ding. The 2 exponent becomes a 1. Ding. And I also multiply by the derivative of what's in the parentheses with respect to x. And you will say there are no parentheses here, but you need to think of it as if there were. The derivative of 3y squared is 6 y to the first power times the derivative of what's in the parentheses. And those 4 things were actually done over here in the red. I just want you to see that 2 times 1 is 2. The x get copied. The 2 exponent became a 1. And we did multiply by the derivative of what's in the parentheses here. I just didn't write it down because dx over dx would be 1. So this red and this blue are really the same thing. You just can't see dx over dx here. You don't have to write that because it's 1. So now I'm going to do the following. Once we have differentiated, that means we found the derivative of each of these, the red, the green, and the blue, then we write the equal sign right here. Write every term that has dy dx on one side of the equal sign. Write every term that does not have dy dx on the other side. So I'll repeat that. Here's the equal sign. These are all the terms that have dy dx. This one and this one. Here's the equal sign. These are over here on this side, the right side, all the terms that do not have dy dx. That's this one and this one. Any term that we move from one side of the equal sign to the other, we have to change its sign. So 2x dy dx, we did not change its sign. It's positive, it's still positive right here. 6y dy dx, we changed its sign from positive up here to negative down here because we moved the blue term from the right side of the equal sign to the left side of the equal sign. This red 2x, we changed it from positive 2x to negative 2x because we are moving it from the left side of the equal sign over to the right side of the equal sign. And the same story with this positive 2y. We wrote it as negative 2y because it was on the left side of the equal sign, 2y, and now it's on the right side of the equal sign. So once we've separated all the terms with dy dx from all the terms that do not have dy dx, then we factor out the dy dx since it's in every term. So dy dx that's common here is factored out in front. Then we divide both sides by all this stuff in the parentheses. I'm going to take the left side of the equal sign and just rewriting it. And the right side of the equal sign I'm just rewriting. And I want to show you that I'm going to divide both sides by whatever that stuff in the parentheses is. Now on the left side of the equal sign, the only thing that's there, because of canceling, is the derivative of y with respect to x. The right side is just all this, just copy. And that's the answer, which can be written other ways. For example, all of these numbers, 2, 2, 2, and 6 are evens. That means this fraction can be reduced. We can divide the numerator by 2, as long as we divide the denominator by 2. That's the correct answer right there. Also, if you want to, this is not required, you can multiply this numerator by -1, as long as you multiply the denominator by -1. And this is the answer that is given in the textbook. But there's nothing wrong with the answer that's above it. Those are equal. Exercise 34 on the same page, 292, says r, which is a function of x, equals 50x minus 0.5x squared. And c, which is also a function of x, equals 10x plus 3. It does not give the profit function. We remember that profit equals revenue minus cost. So profit equals 50x minus 0.5x squared minus 10x minus 3, which is negative 0.5x squared plus 40x minus 3. So we have three functions here. We have a revenue function, which was given, a cost function, which is given, and a profit function that we just figured out. The directions are defined. The rate of change of the revenue. The phrase rate of change of the revenue means the derivative of the revenue. But it says with respect to time. So a dt would go down here. We use something called implicit differentiation because the derivative of 50x is not 50. It's 50 times the derivative of x with respect to time. If we're finding the derivative with respect to x, which we very often do and have done, I would have just written 50 here, because the derivative of 50x would have been 50 times dx dx. The directions got to read carefully. Say the derivative with respect to time. So the next term up here, and then rewrite it over here, is negative 0.5 times x to the second. The derivative of that second term up there is this number 2 times this number, negative 0.5, that's negative 1, times x to the first power, times the derivative of what's in the parentheses with respect to time. And now we're going to finish this question by seeing that it's asking for this derivative when x is 10. So it does say find the derivative of the revenue with respect to time, but it says when dx dt is 5. I'm just getting this from the question. And x is 10. Dx dt is 5. by just plugging in the numbers that are given. dx dt is a number, it's given. X is a number that's given. dx dt is given. So 250 minus 50, that makes the answer $200. And since R is revenue, that's why I put a dollar sign there. But down here is a T, which is time. Time is measured in days. So that's we would label the answer based on this. $200 per day. So we also look at the directions. Want to find the derivative, or it says find the rate of change of the cost. Rate of change of the cost means the derivative of the cost with respect to t. Here's the cost. The derivative of 10x plus 3. In this problem, it's not 10. It's 10 times the derivative of what's next to the 10 with respect to t. And then plus 0 because 3 is a constant. So the rate at which c is changing with respect to t is 10 times 5, because it says in the question that dx dt equals 5. That's 50. I see on the top here is a c, cost measured in dollars. I see on the bottom is a t, that's time measured in days. So we're going to say $50 per day. Dollars per day. And it also says find the rate of change of the profit. The rate of change of profit means the derivative of the profit with respect to t. So here's the profit here in this red circle. The derivative is this number 2 times this number, negative 0.5, that's negative 1, times x to the first power, times dx dt. The derivative of 40x is 40 times dx dt, and the derivative of negative 3 is 0. So we're going to find the rate of change of the profit with respect to time when x is 10, that's given, and dx dt is 5. That's negative 50 plus 200, which is 150. Once again, I look up here, and that tells me this answer, 150, is P, profit is in dollars. Down here's T, time is in days. So $150 per day. All right, Chapter 3, Section 1. Is to learn a new formula for a derivative. Here's a new derivative formula. If we have any number, a means any number, like 2, 5, 12, and it's raised to some function of x. U is an exponent, something with x in it. The derivative with respect to x of anything that looks like that is itself. It is its own derivative. But that isn't all. It's times the natural log of this number. To use this formula, this base has to be a number, and times the derivative of the exponent up here with respect to x. So you are going to need to learn this formula. An example is on page 319, exercise 40. It says f of x equals e raised to the negative x squared plus 8x. And it says differentiate, which means find f prime of x. E is a number. E is a number, it's about 2.7. It's important to know E is a number to know that this is the formula we use. The derivative of any number, doesn't matter what it is, raised to something, is itself. The derivative of this thing is the same exact thing, e to the negative x squared plus 8x, times two more things, times the natural log of that number, which is the base, times the derivative of this exponent. That's the last part there. The derivative of this exponent is negative 2x plus 8. And that's the answer. That, however, can be simplified because the natural log of the number e is actually 1. Natural log of e is 1. So the final answer in the simplest form is going to be the quantity negative 2x plus 8, let's put parentheses around that, times e raised to the exponent, negative x squared plus 8x. Natural log of e is disappearing from the answer because the natural log of e is 1. That's all.